All right, so we're going to start off with graphing of exponential. We see that the value that's being raised to an exponent is 4. That's larger than 1. Therefore, this is going to be growth. Then we need some points. I'd like to have an exponent of 0, and negative 1 would make that work. If you plug in negative 1, my exponent becomes 0. 4 to the 0 is 1. Negative 3 times 1 is negative 3. Minus 2 is negative 5. So negative 1, 5. If I plug in like 0, you might be tempted to try 0. You actually get a negative 14. That's off my graph. So you can change the scale of your graph if you want, or I might actually choose to go with like negative 2. Go backwards. That makes my exponent negative 1. 4 to the negative 1 is 1/4. Negative 3 times 1/4 is negative 3/4. Minus 2 is negative 2 3/4, or negative 2.75. Approximately there. I'm going to jump down to the HA, the horizontal asymptote. It's a y equals, and you look, if it's an exponential problem, you look at your k value, negative 2. It's been shifted down to, so that asymptote is about there. So we can connect the dots, making sure not to touch across that asymptote. So then for the transformations, that negative 3 in front, the negative makes it flip or reflect. The 3, it's bigger than 1, therefore it's stretched vertically. And then in the exponent, the x plus 1, we have to do the opposite of that. So negative 1, that's left 1. And then the negative 2 at the end shifts it. Sorry, I forgot my, I said left, but didn't write how far left. It was left 1. Okay, then it was shifted down 2. My domain, you can, oops, I forgot 2. My domain, all real numbers are okay. My range, it stays below the asymptote, the negative 2. So we'd say that y is less than negative 2. Moving on to number 2, here 1/3 has been raised to the exponent. That's less than 1, so therefore it's decay. Back to the last problem, you may see that it's going down from left to right and think that, oh, it should be decay. But it is growing. It's getting further and further away from the asymptote. It's just going in the negative direction. It's still growth. It's just negative growth. Okay, here we're going to have decay. So for some ordered pairs, I'd like to use an exponent of 0. 1/3 of the 0 is 1, minus 4 is negative 3. I could plug in negative 1. Negative 1 is a nice one to plug in on this one, because 1/3 of the negative 1 is 3. And 3 minus 4 is negative 1. If you would have preferred to go the other direction and plug in 1, that's fine. 1/3 of the first is 1/3. Minus 4, we get negative 3 and 2/3. So that's fine as well. Any of those points can be chosen. The asymptote, I'm going to jump there again. Y equals negative 4. Go ahead and sketch the graph. The only asymptote, there's no multiplier in front. There's nothing in the exponent with the x, so it just went down 4. Domain, you can use everything, all real numbers for every exponential problem. Range, it stays above, y is greater than my asymptote, which is negative 4. Now let's switch to the logarithmic ones. No multiplier in front. This is going 3 to the right, so right 3. It's being shifted up 2. For ordered pairs, I like to take a log of 1, but I can't take a log of 0 or of negative. So you have to be careful. You can't plug in just anything. But if I let my x value be 4, if I plug in a 4 there, 4 minus 3 is 1, and I get log base 4 of 1. Anytime you have a 1 there, doesn't matter the base number, that equals 0. So you have 0 plus 2 is a total of 2. So 4, 2 is one of the ordered pairs. We could try 7. 7 gives us a nice number. It just ends up off the graph. If you plug in 7, 7 minus 3 is 4, so we get log base 4 of 4. Log base 4 of 4 is 1, 1 plus 2 is 3. So 7, 3 is nice, but it doesn't fit on the graph. So either change your scale or allow yourself to go slightly off the graph. 5, 6, 7, 1, 2, 3, more or less up there. We can do that. Otherwise, we could come back and try like, if we plugged in 3 1/4, 3.25, 3.25 minus 3 is 0.25 or 1/4. Log base 4 of 1/4, that's -1. -1 plus 2 is 1. So that's not a bad option either. There are other things you could plug in as well, but our vertical asymptote, it's vertical, so it's an x equals equation. Don't look at your k at the end, you look at the h inside there, but we have to switch signs because it's a k, so it's a positive 3. And so we can go ahead and give our graph the domain. It has to be to the right of that 3. So x is greater than 3. Your range is all real numbers. Number 4, there's no multiply in front, nothing inside, nothing at the end. There actually are no transformations. Ordered pairs, I like to take the log of 1. Log base 2 of 1 is 0. I'd like to take a 2 because log base 2 of 2 works nicely. Log base 2 of 2 is 1. Vertical asymptotes, x equals, there was no number in there, so it's a 0. So connect your dots. Domain, x had to stay to the right of the 0, and your range is all real numbers. For the next section, use your equation y equals a times b to the power of x. A is your initial value. If they give you a 0 for an x value, well, you know that the y part that goes with it is your a. I'll always give you a 0 for these problems, so we know our a in both problems. So y is equal to 256 times b to the power of x. And then over here you have an x and a y, so you're going to plug that in so that we can figure out what this b value is. 81 equals 256 times b to the power of 4. Divide away the 256. We're going to take the 4th root of that. And so when you take the 4th root of that, it would be positive, negative, but my b has to be positive, so I'm not going to worry about that. But do the 4th root of the top and the 4th root of the bottom. The 4th root of 81 is 3, and the 4th root of 256 is 4. So we end up with just 3/4. So then our final answer, your equation, go back and plug in your a, and then your b to the power of x. There's your answer. Number 6 is just like that, but with different numbers. So we plug in 21609 and 4. Divide away the 144. 21609 divided by 144. We can simplify that fraction. Actually simplifies to 2401 over 16. So then once again, we'll do the 4th root of both sides. We only want the positive one. 4th root of 2401 is 7, and the 4th root of 16 is 2. So 7/2. So your equation is 144 times 7/2 to the power of x. Rewrite 2 to the -4 is equal to 1/16. Rewrite number 9. Log base 10 of 100 is equal to 2. Now, we've learned since that log base 10, you don't have to write the 10. It's just understood to be logs. You could also just say log of 100 is equal to 2. Perfectly acceptable. They both mean the same thing. Number 10, we evaluate. No need for a calculator here. 4 to what exponent gives you 256? That would be 4. So 4 to the 4th is 256. Number 11, 2 to what power gives you 1/8? Well, 2 to the 3rd gives you 8, and since it moved to the denominator, it was a negative exponent. So 2 to the -3rd is 1/8. Then we go to the back page. Number 5, you could write them both as powers of 8. You could also write them as powers of 2, but 8 is a little bit easier. So 8 squared to the 3x is equal to 8 to the 2x minus 3. On the left side, we'll get to multiply those exponents together, so it's going to be 8 to the 6x. And then I can drop the subtract the 2x from both sides, we get 4x equals negative 3. Divide by the 4, and we've got our answer of negative 3/4. The next one, they can both be written as powers of 4. So 4 squared to the x. Over here, you have 4 to the negative 3. So that's going to become a 2x there. Now we can drop the base numbers. 2x has to equal negative 3 divided by 2, negative 3/2. Number 7, they're both powers of 9. It is an inequality. That's 9 to the negative 2nd. So I will have to multiply negative 2 times x plus 2. I'll have to distribute, and then I can drop the bases. So x minus 2 must be greater than negative 2x minus 4. I would add 2x to both sides, so we get 3x. Add 2 to both sides, so 3x is greater than negative 2. Divide by your 3, x has to be greater than negative 2/3. Then on the next one, we can't write them, it's a log equation, I guess. So we're going to exponentiate. 4 to the log base 4 cancels, so we get x equals 4 to the 3/2. Well, that means the square root of 4 to the third power. Square root of 4 is 2. Number 13, I have a log base 2 on both sides. I can exponentiate with the 2, but it cancels out both of those logs at the same time. So I get x squared minus 18 is equal to negative 3x. Add the 3x over x squared plus 3x minus 18 is equal to 0. Factor that, x plus 6 and x minus 3. So therefore we get our answers of x equals negative 6 and x equals positive 3. But you need to check those answers. Make sure they work. And notably on this one, the 3 doesn't work. If you plug in 3, you can plug in right here very easily. Negative 3 times 3, you get negative 9. We can't take log of a negative 9, so therefore we have to throw that out. But when you plug in negative 6, negative 3 times negative 6, positive 18, that's okay. Plug in over here, negative 6 squared is 36, positive 36 minus 18 is 18 as well, so that works. Number 14, we're going to exponentiate. It is an inequality, so we'll have to check the domain. 4x minus 6 is greater than 2x plus 8. Subtract your 2x from both sides, add your 6 to both sides, divide by 2. There we go. But when we check our domain, we know that, I'll do the 2x plus 8 first. It has to be greater than 0. Subtract 8, negative 8, divide by 2, you get negative 4. So x has to be greater than negative 4. Additionally, the 4x minus 6 must be greater than 0. So add the 6, divide by 4, 6/4, applies to 3/2. So x has to be greater than 3/2, and it has to be greater than negative 4. Both of those. So we can narrow those two both down into this. It has to be greater than 3/2. If it's greater than negative 4th, it's not a guarantee it works in both. This works in both of those. But now check your answer. X is greater than 7. Oh yeah, all of that is greater than 3/2. So we don't have to restrict our answer. X is greater than negative 7. That's our answer. X is greater than 7, not negative 7. Starting with number 15, we have to condense logs first. So we have to take the two logs, they're added together. That means we multiply those. So we have to take x times x minus 4. I'm going to go ahead and distribute that right away. X squared minus 4x equals log base 4 of 5. Now I can exponentiate with the base of 4, cancel out both logs at the same time. So x squared minus 4x is equal to 5. Subtract the 5 over the factor. So we get answers of negative 1 and of positive 5. Plug them in and check. Notice the first one, the negative 1, if you plug it in here, log base 4 of negative 1, not allowed. We can't take it of a log of a negative. Log base 4 of 5, that's fine. 5 minus 4 is 1. Okay, so that one works. Number 16, We have to condense again. It's a base of 10. I don't have to write the base of 10. So z times z plus 9 is z squared plus 9z equals 1. Okay, now I'm going to exponentiate using the base of 10. 10 to the log cancels on the left side, so z squared plus 9z is equal to, here I have nothing canceled, so 10 to the first is 10. Subtract the 10 over. Factor. Oops, that wasn't, yeah, there's these. Z plus 10, z minus 1. So I get answers of negative 10 and of positive 1. Plug in the negative 10, cancels out right away. We can't use it because you can't take a log of a negative. 1 looks like it's going to work just fine. Number 17, condense. Get x squared plus 30. Sorry, no, that's not true. I don't know why I said 30. I was thinking of my base instead of what I was actually multiplying by. Distribute the x. X times x is x squared. X times 5 is 5x. Now we can exponentiate with the 6. So x squared plus 5x is equal to, over here I have 6 squared, which is 36. Subtract the 36 over. So when I factor that, x plus 9, x minus 4. So we get x is negative 9, and I get x is positive 4. Plug negative 9 in, it doesn't work, so we just get x equals 4. Number 18. Once again, I don't have to write the base of 10, just log, and then we can do subtractions. We do a fraction 18 over 3x, which of course I can simplify that because I can divide them both by 3. So log of 2, exponentiate with the 10. That should have been a base 2 over there. That 2 is really up here. Let me erase that, fix that. It was log of 2. Okay, so we get, that simplifies to 6 over x is equal to 2. I've multiplied both sides by x. So 2x is equal to 6. And so x has to be 3. Looks like that'll work. We don't have any extraneous solutions. Okay, now I'm going to log base 8 of both sides. That way I cancel out the 8 over there. I get x plus 1 is equal to log base 8 of 30. And then I can subtract 1 from both sides. So x is equal to log base 8 of 30 minus 1. Plug that into your calculator. We get about 0. Point tells us 4 decimals, 0.6356. Number 20, I'm going to log with the base of 6. That way I can cancel out that 6. So I get x squared. It's equal to log base 6 of 28. To solve that, I'm going to have to square root it, and then I'll have to do plus minus. Plug that in your calculator, you get about, and it is plus or minus, you get about 1.3637. Number 21, I'm going to log with the base of 3. Four x is less than or equal to log base 3 of 72. Divide by 4. X is less than or equal to, we get about 0.9732. Number 22, I need to add the 11 over first. Divide by 4. Natural log both sides. That way the ln cancels out the e, so I get x is equal to ln of 7. You can plug that in your calculator, and we see that x is about 1.9459. Number 23, I would first add the 5, divide by the 3, ln both sides, so we get 2x is equal to the natural log of 1/3 divided by 2. So in the calculator, do natural log of 1/3, divide that by 2, and we get about negative 0.5493. Number 24, subtract 2 from both sides. Natural log both sides. X is greater than the natural log of 7. Plug that in the calculator. We see that x is greater than 1.9459. Number 25, I'm going to exponentiate both sides with an e. So I get 2x is equal to e to the 6th. Divide that by 2. So on the calculator, do e to the 6th divided by 2. And I get about 201.7144. It is a log equation, so I do need to make sure that works, but it's not going to be negative when I plug it in, so it works just fine. 26, exponentiate again with an e again. So x plus 3 is equal to e to the 6th. I have to subtract 3. So x is equal to e to the 6th minus 3. Plug that in the calculator. We get about 400.4288. Once again, no problems when you plug that in. Then we get into the word problems. Okay, we're saving compound monthly. So compound interest problem. You want to have 5,000 at the end. We're trying to figure out what to deposit, but we want 5,000 as a final answer. We don't know how much to initially deposit. We don't know what our principal is. 1 plus our interest rate is 3%, so 0.03. It's compounded monthly, so we get a 1/12 of that each month. We're going to get interest 12 times a year, and we're looking for doing this in 2 years. So times 2. And I need to figure out what P is. So looks like I need to divide both sides by 1 plus 0.03 divided by 12 to the power of 24. And P will equal that. Make sure you're careful with parentheses on the calculator. But we see that we should deposit $4,709.18 in order for us to have $5,000 in 2 years. 28. Interest is compounded continuously. So we pick our equation accordingly. We're trying to figure out what our balance is at the end. We know our initial amount is $350. Since it's compounded continuously, it's e to the power of our rate. Change it to a decimal, so 0.032 times the number of years, which is 8. Plug that into your calculator, and you see your final answer, $452.11. Number 29, we're depositing 2,000. We want it to triple, so that means we want 6,000 at the end of our time. Initially 2,000, compounded continuously again, so same equation, times e to the 0.064 because of that interest rate, times t, we don't know how much time, that's what we're going to try to figure out. So first step, divide away the 2,000, giving you with 3. So 3 equals e to the 0.064 t. Now we're going to ln both sides. So 0.064 t is equal to the natural log of 3. So then we have to divide by 0.064. natural log of 3 divided by that, and we see that it's going to take about 17.2 years. Okay, number 30, we're talking about a half-life of 32 years. So we want to end up with half of what we started with. It's continuous, so E. We don't know what K is, just decaying, so it's negative K times T, but we know it took 32 years for it to become half. So we start with this equation. We're going to ln both sides. We run any half-life problem, it ends up looking like this. So we're going to divide by the negative 32. Really, anytime you have a half-life problem, you can do the ln of 1/2 divided by negative however many years it was to get your K. And so we see that our K value is about 0.0217. And they say to write the equation for this substance. Well, it'd be y equals A, whatever the initial amount is, times E to the negative K, so negative 0.0217. That was a messy, zero there. I don't know how that was a zero. That's better. Times T for the number of time. There's our generic equation for any question using that radioactive substance. And then lastly, I've got to figure out how to get some room to write. We know the K value. They give us the formula. We want to start with 10. We want to end up with 675. 0.728. And we're trying to figure out how much time. And T is the number of days. So we divide by 10. So 67.5 is equal to E to the 0.728 T. So now we're going to natural log both sides. So 0.728 T is equal to the natural log of 67.5. We'll divide that by 0.728 to get our answer, about 5.8. It says here, this is the number of days. On my answer key on Canvas, I wrote years, but I didn't read it very well. It should have been days.